Hello and welcome to another Biochemistry Optical Core tutorial training video. Today I'm going to be talking about the basic Bach NSIM startup. SIM, of course, standing for Structured Illumination Microscopy. This is one of the three instruments we have on hand here in the Bach, and it's one of the super resolution options that are available as well. It is going to offer roughly about 2 times the resolution improvement over our standard confocal, but it's not going to be quite as high resolution images you would acquire with something like Storm. So it sits kind of nicely in the middle between those two instruments. And luckily, it's also very simple to use and relatively easy to get going as well. So let's go ahead and dive right in. To get started with, let's talk about what is SIM actually, and then we're going to talk about just basic SIM startup. And then following these two introductions, we're actually going to go into taking a SIM image and how to go about doing that in the SIM software elements. So let's just start with what's SIM. SIM stands for Structured Illumination Microscopy. Its whole modality is based around structured light. So what is this structured light? The key concept for understanding this is actually something called moire fringes, which is something you can see every day. Basically, one example that you might see is on the highway or interstate. You see these bridges that are overpasses, and what you might notice is that when you look at the fences on these overpasses, you'll see some kind of weird patterning or interference pattern that develops between the two railings that are superimposed on each other. So see, here you can see there's like darker areas, there's lighter areas. This emergent interference pattern you see here is actually key to understanding the structured light we'll be talking about with the microscopy. If you were to just take two patterns here, just like we were talking about with the railing above, it turns out that by superimposing them, the interference between those two patterns can reveal some finer details. You might already be cluing in that this can be very helpful if you have a biological sample that you otherwise wouldn't be able to see fine details with because of the resolution limit of light. You can tease those details out by using some structured light pattern. To be little bit more explicit about this, if you have some kind of a structure or pattern and you've got a biological sample that has its own structure or pattern, then if you were to superimpose the structure or pattern, you could achieve some finer detail out of it. And it turns out that if you just rotate that pattern and repeat this many times over, about 9 to 15 different times, you will achieve a really wide range of resolution improvements over the standard wide field, like basic microscopy technique. So this is really powerful because all we're really doing is superimposing some structured light onto our sample. We're not changing the optics substantially, although there are definitely differences in the optics compared to a wide field. But the approach for doing this really only requires that we take a few different images. All of the actual structured illumination microscopy magic will happen once we've taken the images and we need to actually reconstruct that image. The way this might look, if you were to kind of stare at the objective, is while the structured light is happening, you can see in this video that the light kind of rotating around at many different angles. So in practice, you're just going to take many different images with each one of your lasers at different angles and then use those images to reconstruct a higher resolution image. So what does this actually look like? Well, I went ahead and took an example image of just some cells here. This is just a standard wide field image taken with the objective on our SIM image, but I took it with the basic wide field settings, so without any kind of structured illumination technology going into this. And then I repeated the same field of view, but now I did SIM. And hopefully what you'll see is that you can definitely see, especially with our green label here, you get much finer detail in that. So you see much finer detail in those structures. And that's one of the really great strengths of SIM, is that if you have finer structure in your images, you can really tease that out using SIM compared to just a standard wide field setup. And it doesn't take that much longer to acquire a SIM image over a wide field one. So that's SIM. Now let's actually talk about how to actually start up our SIM instrument here in the Bach. So the first thing you want to do is just turn the keys for the lasers that you'll want to use for your experiment from standby to on. And we have 4 different lasers, so that means we can have 4 different excitation sources here. And we have the 405, 488, 561, and 640 that all represent sort of the standard fare for lasers in microscopy. So once you turn those to on, they'll take about probably 5 minutes to warm up, and then they'll be fully ready to go. Now, if you're going to be using epifluorescence, which I definitely use myself whenever I'm getting my sample into focus, you'll just want to make sure the solar light engine light source is actually on. It should be on by default whenever you come into the room, but just in case it's not, the power button is located where that red arrow is, and you'll just want to go ahead and turn that on. The next thing you'll want to do is to add a drop of immersion oil to the 100x objective. And then you'll just want to place your sample on the stage top with the cover slip facing down. And finally, you're just going to want to turn on the workstation and log in using your Whisk ID and password. And then once the computer's booted up, you're actually ready to go, and you can go ahead and start Elements. So now we're ready to open Elements and acquire a sim image. And so what I want to do for the next little bit is just talk about the settings that go into doing this and the approach you ought to take to get a sim image. So here we are. Now we just want to double click on the NIS Elements software. I've actually already done this in Open Elements because it does take a few minutes to load. But once you've opened this, it'll prompt you to either create a new user profile, which you can certainly do, or to load up a current user profile from maybe someone in your lab who's already used the instrument. So once you've selected that, it'll also prompt you whether or not you want to use the Andor Ixon plus NSIM module, and you'll just want to hit OK. So once those prompts have been okayed, it'll finally load Elements. And what Elements will look like when it loads up is just this blank screen. Now I'm just going to load up the very first module I want to talk about briefly, which is our tie pad. And by the way, anytime you want to load a module in case it doesn't appear, you just want to right-click anywhere in the blank area, go to Acquisition Controls, and more than likely what you're looking for is going to be in one of these options. So we're going to go to tie pad. And the tie pad is just, the TI is the actual microscope. So this is the pad that allows us to control that microscope. You can use, pretty much all of these controls are available on the microscope itself in physical form. But you'll probably find it's easier to do all these controls just right here in this single module. So again, this is for the microscope itself. This has nothing to do with SIM. It's just the microscope. That's kind of highlighted here by the first set of options are just changing the objectives around. The next thing I want to draw your attention to is this light path button. The E100 is what it's currently set to, and that just stands for the eyes 100%. And that just means that the light is going 100% to your eyes. So this is for if you're using the solar light source for epifluorescence imaging, most likely just to get your sample into focus. So that would be my first step, actually, is to get my sample into focus. And I've done that already. But the process by which you would do that would start here. You would want to go ahead and set your eye ports or the light path to the eyes. By the way, for SIM, we're going to use the R100 option. So that's going to send all the lights to the right where there happens to be our Andor Ixon camera. So whenever you do SIM, this needs to be on R100. Finally, the last thing I want to talk about here is just these turrets. These turrets are for all of our filter cubes. And basically we have 2 turrets because one of them is just for epifluorescence imaging and the other one is for SIM imaging. And in fact, if you hover over these, you'll see turret 2 here is, this blue one is for DAPI, green is for FITSI. This top row here, all you need to know is if you want to see DAPI, you can just select this blue square here, and that will automatically move the filter to that, so you can look at DAPI with your eyes. Similarly for FITSI or any kind of green fluorescence or maybe TRITSI or some kind of orange or red fluorophore that's in there too. However, if you want to see with your eyes, this turret 1 here actually needs to be empty. So if you want to see fluorescence with the eyepieces, make sure this turret 1 is set to empty and turret 2 is set to the cube that corresponds to the fluorophore you want to see. Conversely though, if you want to use SIM, then this needs to be set to empty and this needs to be set to one of the laser wavelengths you're interested in using. And in fact, if you hover over these, you can see this as SIM 488. So this is meant for the 488 laser line for doing SIM. And similarly for 561 and 405 as well. So that's what these 2 filter turrets are for. Okay, so that is everything for the tie pad. Now let's move on and open up another panel. Real quick, let's just open up this solar pad. This is just the controls for our Sola epifluorescence light source. Up here is just the light intensity, and this right here is just the shutter. So if you want to see the light, this needs to be turned on. And of course, you can turn it off at any time, which I would do in between imaging. Another thing I'm going to draw your attention to is just our OC panel. I did an entire video on optical configuration, so view that video if you want to learn how to make an optical configuration, which is essentially just a preset. Right here I have a number of presets I've made for my own personal imaging. You see I have presets for just looking with the oculars, so this would be the epifluorescence mode. I have two different SIM optical configuration panels here, one for 2D imaging, which I'll get into in a second, and one for 3D imaging. And finally, just for gut checks, I like to have a wide field set as well. And these are just images acquired like you saw just a couple minutes ago in the slide, where it basically mimics a wide field approach. So this is not SIM, this is just wide field. And I like to use this just to compare how the resolution might appear for 488 versus something like SIM, and just compare the two and see how they look. Now let's actually talk about the SIM controls, because up to this point, everything you've seen here, with the exception of this filter turret right here, has been just for epifluorescence or just operating the microscope itself. But this next module is strictly for SIM. So I'm going to navigate again to the NSIM pad. And so there's a number of different settings here. This is where all the magic happens with the SIM. This is how you're going to actually manage the laser lines and then reconstruct your images. This is your live mode. You don't need to worry about any of these options. These are just different options for how the pattern of structured illumination will operate in live mode. You just always want to have it on moving. Unless, of course, you use one of these wide field settings, you'll want the wide field setting selected. But for almost everyone, you're going to want to just keep this at moving. There's a capture button up here where you can just take a simple image for SIM. It would be the same thing if you were to use the ND acquisition window, which I'll show you in just a second how that works. But this is just for capturing images. This drop-down box here, this is going to dictate whether you do 2D SIM, which is, I believe, 9 images, where it will take 9 different images at different angles, like you saw earlier. And the other option is to do 15 images, which will incorporate some of the Z correction or Z reconstruction SIM. There is a turf sim option on here, which I'll mention, but I should say that if you want to do turf, you should let me know, and I can go ahead and change over some of the optics to allow you to do this turf sim. So I'm going to preempt myself and just go ahead and select 3D sim here, because I'm going to want to do 3D sim for my imaging. Okay, so now I'm just going to skip on down here to the laser control. And this is pretty self-explanatory. You have the shutter here. This is 405 currently selected, so the shutter is open, allowing the 405 laser in. And it's currently set to 48.8% power, which is, I would say, a pretty high level of laser power. But that's going to be something that you will have to determine when you look at your image. Obviously, higher laser powers are going to contribute more to photo bleaching, but they will give you a better signal. So that's just going to be something you'll have to decide when you're imaging. So all that information applies for the 488, the 561, the 640. You cannot image multiple lasers at once. Because as you see, if I try to select the 488 while the 405 is selected, it will deselect the 405 and it will only select the 488. So unlike on something like a confocal, where you can image multiple laser lines at once, this only allows you to use one at a time. And finally, what I want to talk about is just these different reconstruction parameters. And this is not something I'm going to go into a huge amount of depth with today, because I'm going to do an entire video on how to do SIM reconstruction. So because I'm not going to go into too much depth today for reconstructing, I'm just going to draw your attention to this reconstruct slice option. So you can just hit this button and it will reconstruct a slice, basically your images that you acquired. It'll reconstruct those with default parameters. Okay, and so that's the settings for the NSIM. There's 2 more windows I want to open up for us. One of them is going to be our actual camera settings. So the DU897, confusingly, is the camera, and that is our Andor camera that we're using. So these are the settings that control that camera. And really the only options you need to be primarily focused on are the exposure time, which here it's at 20 milliseconds, which is a very fast exposure time, and that's just how long the camera is going to be acquiring an image for. So the longer this value is, the longer it'll take to take an image, and the brighter your image is going to look. But of course, you're exposing your image to a lot of light in that time, so it's worthwhile to find a happy middle ground between maybe a really longer time and a shorter time where you can really optimize that exposure time so you don't harm your sample. And again, I think 20 milliseconds is a pretty short one. You really start getting into longer times when it's like 500 milliseconds to a second. But if you need that to acquire an image, it's totally fine. You just have to be aware of the caveats that go with acquiring longer images as it pertains to photo bleaching and things like that. The other thing you want to go ahead and adjust whenever you're optimizing your settings is this EM gain multiplier. Basically, it's just gain. So it's going to artificially bump up the brightness of your image while also introducing noise. So again, this is just an optimization parameter where the higher this value is, yes, the brighter your image is going to look, but you're also going to be increasing the noise threshold and your image will look noisier as a result. I consider 300 to be pretty high, whereas I think 100 or less is on the lower end. And that's actually ideal. So if you can get an image where your gain is low, that's going to be ideal because you're introducing less noise into your image. So these are the camera settings. You can basically ignore these other settings, although I would go ahead and keep it on 5.1. Make sure you're not doing any binning, and make sure this is set to the highest EM gain, 10 megahertz at 14-bit. Okay, so the next window I want to open is actually not under acquisition controls. It's under visualization controls. I always open this because what this LUT or lookup table window will show is basically photons that are being detected by my camera. And this is going to clue me in about how bright or how many photons I'm detecting and how good my image quality overall is. So now I've introduced you to all the windows. These are really the primary windows. There are of course other ones, but these are the windows you need to really get going on your image. And what I want to do now is go ahead and press play and start optimizing my image settings. So if you're following along, what you've probably done at this point is got your sample into focus using epifluorescence and then switched gears, and now you want to focus on getting the best settings for your camera for sim. As I said, I'm going to use 3D settings. You could use 2D settings. There's nothing wrong with doing that. I just have gotten the habit of doing 3D, and I think for this sample in particular, I think it does a great job of doing reconstruction for that. Okay, so I'm going to do this 3D 488. Turns out the 488 and 561 channels are nice and bright for this sample. And I have some default settings I've already selected here. You do not need to use these settings. This is just what my preset is already selected here. Oh, one more final caveat. The 3D does not mean it's going to make a volumetric measurement. I'm not going to get a Z-stack out of this. So that 3D is misleading. It's not what you think it is. Because basically, by taking a number of images, 15 images to be exact for this 3D image, for this 3D sim option, I'm going to be able to reject out of focus light that might be slightly above and below my sample, and therefore get a more crisp looking sim reconstruction. So that's what this is doing. It's helping me to get rid of unwanted out of focus light that might be elsewhere above or below my sample. Now with all those caveats out of the way, let's just hit play and let's see if this is going to give us any kind of response. And luckily there is something in here. What you see here is just our green fluorescence, but it's pretty dim. So I'm just going to kind of move this LUT window. And now what I'm going to do is just get this into focus a little bit. Great. So you might be saying, looking at this, what are these lines? And that looks pretty bad. But in fact, those lines are exactly what you need to see in order for the sim reconstruction to happen or to work the best. Because these lines are actually that pattern. That's the pattern of structured light that we are superimposing on our sample to help us tease out the finer details in our image. So we need to see these lines. They need to be in focus in order for us to get a really good sim reconstruction. And this needs to be the case for all of your channels. So if you don't see these lines, you're going to have to either optimize your image settings more, or you're going to have to change these parameters around for reconstruction. On the biology end, you could also just work with your sample labeling to get them even better and brighter, because basically these lines are easier to see the brighter your sample is and the higher the signal to noise ratio is. Okay, so looking at this 488, when I'm doing this, I'm not going to go into too much detail about optimizing my imaging settings. I have, like I said, an entire video devoted to that. But from that video, you'll probably know that this is actually really good. This is roughly half of the dynamic range of my detector. So I'm pretty happy with that. And as I said, I can see the structured illumination pattern on top of my sample. So I think it's all good. I'm happy with the 488. I'm going to repeat this just for the 405 and the 561 and check those settings to make sure that all those are correct as well. So here's the 405. Again, we see our pattern moving back and forth across our nuclei. This is a DAPI staining. Just for reference, let's say, for instance, that I wanted to adjust the laser power from 40 to 45. That's very easy, and I want to do that because looking at this, I can see it's roughly taking up a third of the dynamic range, so there's room to breathe here. So if I just adjust this to 45, I'm just going to look and see what this looks like. I can see it offered a little bit of an improvement, so I'm going to actually go with that. And I'm going to now right-click on my optical configuration. You can either right-click here or here. They do the exact same thing. So right-click and assign current camera setting. And now my preset has been updated with the new laser power intensity. Okay, so now I'm going to repeat this for the 561. So when I look at this, I can definitely see the patterning here, but when I look at my lookup table, it's very bright. So I need to reduce some settings here to make that better. So as I said, I usually like to go ahead and I like to adjust my EM gain multiplier to make that, to lessen that. So I'm going to lower it from 200 to 150. It's still pretty bright, so I'm going to do 125. And that looks really good to me. Again, all I'm really looking at here is my lookup table. I can see the patterning, so I know it's in focus there. So I'm going to hit stop now. I'm going to update my preset again. And now what I've done is I've updated all three of the presets, optical configurations that I'm going to use to ultimately acquire a 3-channel SIM image. So how would I go about doing that? I've done the optimization, now I need to acquire an image. So you could, if you wanted to, go to each one of these presets, hit capture, and do it that way. That's certainly one way of doing it, but I think that requires more clicks and more time and more focus on your part for doing the actual imaging. I think a better way of doing this, and one I think that Nikon has actually implemented fairly well into the software, is to use the ND acquisition window to use our presets and acquire one image that way. You can right click again, acquisition controls, ND acquisition. So here, there's a number of different options. You can, of course, this directs you where you want to save your images, what you want to name those files. And then down here, we have different tabs. So we have time, X, Y, Z, large image, and lambda. Lambda is really the only one I personally work with when I do SIM imaging. And if you were to open this for the first time, there probably wouldn't be any optical configurations here that were populated. So you can just start by just clicking this empty box here. And then I'm going to navigate to my 3D optical configurations that I've made. And I'm going to just do this for the other two as well. I don't think the order really matters here, but I am going to go in numerical order. Okay, so now what this is going to do is it's going to acquire those 3 images that I otherwise would have to hit capture 3 times to do, and it's going to merge them all into a single image. And so let's go ahead and do that now. Okay, so it finished its image acquisition, and I just want to draw your attention to a couple things here. The first thing is that when you actually look closely at each one of these images, you'll probably see that at each row, it looks like the structured illumination pattern is at a different angle. And that's, of course, because it is. In order to make this 15 image set, it just took images at many different angles. And what we're going to do when we reconstruct is merge all of those and do some computation behind the scenes to get a structured illumination image. Another thing I want to point out is because we did all that back-end work trying to optimize our settings and then saving those settings into presets, the image itself out the gate looks really good. You see the orange, blue, and green are nicely contrasted, and that just means we have to do less work now to make those images look better. So again, I mentioned that it's going to be 15 images it acquires. That's what we see here. Now what we can do is just we can do the reconstruction here on this workstation. So as long as you have this set of 15 images, this ND2 file, this is what you're going to be ultimately using for reconstruction from then on. So if your time is short, you can just acquire the images and do the reconstruction later. But as I said, I just want to show you real quick before I go today about how to just do simple reconstruction. So I'm just going to hit Reconstruct Slice. Now what it's going to do is that computation in the background and give us an image reconstruction. This window will pop up. It gives us a score. 8 is the highest. This score, take with a little bit of a grain of salt. It's not always going to give you an 8 potentially, but it's going to give you a higher score if it can find those interference patterns, those or that structure of lines. If it can find those, it's going to give you a higher score because it can do a better reconstruction. So I'm just going to hit OK here and show you what this looks like. What will likely be the case is you have to do some adjustment of your lookup tables to make this look a little bit better. So at that point, you've done it. You've made a reconstructed image, and then you've made some adjustments, and you're actually finished. You can save this image if you want to as an ND2 file, which I do recommend because the ND2 format is the standard project file format that saves all your metadata and allows you to go back in at any time and make adjustments. So I'd make sure you save this as an ND2 file, and then you can also save them as TIFF files or JPEGs or whatever file format you want to. But as I said, at that point, you're done. The process now, if you were done for the day, is you would want to go ahead and exit out of Elements. You don't need to worry about exiting out of all these windows. In fact, I would keep all of these windows open because they'll reappear the next time you open your user profile, so you won't have to right-click and open them all again. Keeping all these the same as they are, I'm just going to exit out and hit OK. I am not going to save these, so I'm just going to close them all. And then the process for for finishing off your experiment today is going to be shutting down the workstation and then doing everything in reverse. You'll want to take your sample off the stage, wipe off any residual oil that's on the image using sparkle and lens tissue paper, and then you will go ahead and turn all the lasers to standby, and then you're good. So with that, you've completed your sim experiment and you're ready to leave for the day. And I guess with that, I'm going to leave it here for this video. Thank you for watching.